So we introduced rectangular coordinate system, cylindrical coordinate system, and spherical coordinate system, and the logic behind them. Remember that when we defined dA in coordinate rectangular coordinate system was defined as dx dy or dy dx, and then we moved to polar coordinate system. dA was converted into r dr d theta. So when we are in 3-dimension, dv is defined as dx dy dz. In cylindrical coordinate system, dv is equal to r dz dr d theta. And when it comes to spherical coordinate system, we're going to have a very special case. In that special case, dv is equal to, so just erase this, is going to be written as rho squared sine phi d rho d theta d phi. So remember that when you are using rectangular coordinate system, we have dx dy dz. In cylindrical coordinate system, dv or the volume element converts into r dz dr d theta. And then it comes to spherical coordinate system, it becomes rho squared sine phi d rho d theta d phi. How? What's the reason behind it? Take a look. So suppose you have a slice of your spherical object. Okay, so let me write this down here for you so we have enough space. So suppose you have your x, and then y, and then z, and you're looking at a very small piece of your spherical object. How do I visualize that? Suppose we visualize it this way. Have this guy here, and then let's just try our best to make it a little bit pretty. Okay, here we go. This object, and this side. Let's have this side. Okay, tilt it a little bit. That's fine. You get the whole idea behind it. And this is a little piece, very small piece. So I want to calculate this little volume. What is dV? How do I compute dV? Well, based on what you learned before, if it's a very small piece, you have the multiplication of base, height, and the length. You multiply them all together to find this dV, a very small piece of your volume. So what are these? How do I compute these? Remember that you had your phi here. This is the angle between the positive part of z-axis and the line connecting the point to the origin. All right. So take a look at these parts. We're going to try to relabel these using our rho, our phi, and the rest of them. If I look at the projection of this piece in the plane, it's going to be similar to this. Okay. Let's just move this a little bit here to get the big picture. In this piece, remember that this guy is located in xy plane, and remember, this is your angle. For example, just write down the angle theta here and show that this is going to be d theta. The very small change that you see in theta. Okay, so since this part is your d theta, the other part is going to be your d phi, all right, this part. So this is your d phi. It's going to change very small change in the angle phi. Perfect. What is this definition? Erase this line. The definition of this line, as you remember, is rho. All right. So far, so good. We have a rho. Now, take a look at this piece. What is the measurement here? How do I measure this value? Or I can compute this as well. What is this measurement here? These are the things that I need to find, then do the multiplication. This is rho, and I can call this guy d rho. I don't have any issue here. But the pieces that I need are these two pieces here. This piece here is going to be equal to rho sine phi d theta y sine phi d theta. And the other piece here is going to be equal to rho d phi. Well, how do I see that? Remember, when you have a piece of pie, and if you have the central angle like alpha, and you have a measurement like r here, you're able to compute this little piece up here. This is your arc. You can find the length of the arc. All right. The length of the arc is equal to r alpha. So take a look at this. Here I know that this piece is equal to rho. All of these are the measurements, or the distance between the origin and the point. Rho, rho, rho. So this piece, as you remember, it's going to be d phi. The very small changes in phi. D phi times rho is equal to rho d phi. So we found this piece. We already know that this piece is d rho. What about this guy here? How I got this element, this measurement here. For that measurement, you have the following scenario. Here you have your rho, and you know that this piece is projected in xy plane, and you have your d theta down here, right? Since you have d theta, and this guy is your r, you have r d theta as the length of down here. But what's the definition of r? R is defined as rho sine phi. This is rho sine phi. So here you get r d theta, which is rho sine phi d theta. Very good. So dv, as you can see, is equal to, let's just multiply this. You have the length here, rho d phi. You have a length here, rho sine phi d theta, and you have another length here, which is d rho. Just multiply these together, and dv becomes rho squared sine phi. Well, we can write it as d rho d theta d phi. So later on, when we are calculating different types of integrals, we might be switching this around or use Fubini's theorem to separate the integrals as well.